So here we have a homeostasis question. Homeostasis is keeping our internal body conditions the same, and that's predominantly for chemical reactions, which need to have a consistent temperature because of enzymes activity, pH, because pH can change the shape of enzyme active sites too, and we also need osmoregulation, which keeps the dilution of solutions the same in order that chemical reactions can occur and there is not osmosis causing water to move from cell to cell in an uncontrolled fashion. So this is about temperature. And so we have a graph here. On the y-axis, we have amount of energy lost in joules per second. And we have internal body temperature on the x-axis going from 36.2 to 37.6. So if this was a describe question, it'd be asking us to say what we see. So we describe the fact that it stays at a constant level until 37 and then increases in a proportional way in a linear fashion from 37 upwards. But A here is asking a direct mathsy question, and it's simply asking us effectively how much energy is lost at 37.6 compared to 36.6. So here we have our level of 37.6 and 37.6 there, 36.6 is there, and so it is the difference between those two. Okay, and you can see that's 350 joules. Note here it says show clearly how you work out your final answer. So you do need to put in those figures so at 37.6 equals 360 and 36.6 equals 10. 360 minus 10 is 350 joules per second. 2 marks. Notice that they've already given you the units, but if it was for 3 marks or that wasn't there, then you'd need to write in joules per second. We always need units. Okay. Explain why a person would feel more thirsty when the body temperature is 37.6. So you're losing more water because you're sweating more. Okay, so we're using a bit of your common sense here, and if your body temperature increases, then you are losing more water because of sweat, and if you lose more water, you become dehydrated, and it's the hypothalamus, and I think that might, as you might mention on the mark. So if we look at the mark scheme over here, more sweating at 37.6. And notice the way it says more sweating. Okay, this is really important actually, and this is exam technique. Whenever they're asking a 37.6 to 36.6 question, and often there is the word that's needed in these answers is more. Okay, there is more sweating at 37.6. You wouldn't say that there is sweating at 37.6 because there will be some sweating at 36.6. So you need more sweating, therefore more loss of water. And if we do start to dehydrate, our blood becomes more concentrated and our hypothalamus picks that up. And therefore you would send stimulus to your thirst centers and effectively tell the body to drink more. Okay, if we look at them, so blood becomes more concentrated, salty, and stimulation of the hypothalamus. Okay, so that is a key exam tip there, is more. So explain how sweating helps control body temperature. Well, this is to do with water and evaporation and the specific heat capacity of water. So you may remember from your physics that the specific heat capacity of water is 4,200 joules per kilogram, and that means that to raise the temperature of water by 1 degree C, 1 kilogram, you need 4,200 joules. So it's got a very high specific heat capacity. That's actually because of the hydrogen bonding that means it's difficult to increase the temperature of water, and it's even more difficult for water to evaporate, because remember, when you evaporate, you break the bonds. It goes from the liquid to the gas phase, and you're breaking the bonds that keep it in a liquid with the particles close together and allow them to become singular water molecules in the vapor state. So sweating is a brilliant way of the body losing temperature, because if you go from the liquid to the vapor state, you are having to invest energy to break those bonds. And water, as I said, because of hydrogen bonds, has a very high level of energy required. And so you can see on the mark scheme here, key terms that we need to put in are evaporation of the water, underlined means you must mention water, and that cools the skin or uses heat from the skin, cools the blood, heat from blood. Okay, so in this, the answer that I would give would be that water on the skin going from the liquid to the vapor state, evaporation, the energy required to cause that evaporation is drawn from the skin, it cools the skin, and therefore in turn cools the blood.